Let's see, record to computer. There we go. All right. Hello, everyone. So last time we finished up lesson 6, which was our introduction to programming. And hopefully you all were able to submit that since it was due already. But if you haven't already, make sure you do that today so that I can grade it over the weekend and give you feedback if you need it. Today we are going to get started on the next lesson, which is lesson 7, and we'll be able to finish most of it today. So lesson 7 is on debugging, which has to do with both identifying and fixing problems in code. And there's different kinds of problems that we'll actually notice today. So one type of problem actually breaks your program and it won't even run. And other types of programs other types of problems won't break your program, but it'll cause your program to act in a way that you don't want it to. So we'll take a look at a couple different examples today. So again, this is lesson 7, and we're gonna start with puzzle number 2, because puzzle 1 is really just a description of what this unit is about. So I'm going to go ahead and I'm going to put that link in the chat so that you can do this along with me if you feel like if you feel like you're able to kind of keep up as I'm explaining, you can do that, or you can simply watch and do it afterwards, because I will be posting the video after class as well. All right, so I'm going to go ahead and I'm going to start this over. All right, so for each of the puzzles, there's going to be something wrong with the code at least one thing wrong with the code that we're going to have to fix in order to get the program to work the way that we want it to. Now, for debugging, it's actually going to be a little bit easier for most of these to actually be in text mode so that we can make edits a little bit more easily. So for this one, it says debug the program. And it also kind of reminds us that we can slow down the execution of our program code if we use this slider. And that's going to make it's a lot easier to see what the program is doing step by step, because otherwise things happen so quickly that we can't really observe what's going on. So I'm going to go ahead and I'm going to move this all the way to the turtle to make it go really, really slow. The other thing is that when it's in text mode like this, we can actually see the different lines of code highlighted as we run it. So if I click run, you see how there's a yellow highlight on this line. And then we can kind of see that something goes wrong. So on this line in particular, it highlights for us. So on this line, it says green hasn't been declared yet. And we haven't really talked about what declare means yet, because we haven't really talked about variables yet, which we will get into, but briefly I'll kind of tell you what that means. So declare means to create a named variable, and variables store values, okay? Now it thinks that green is the name of a variable because notice that there's no quotes around it. And we're used to seeing text being surrounded by quotes. And if you remember, we talked about this type of data, a data type. Yeah, thanks, Jesus. It's the quotes that it's missing. And this data type is called string, right? So whenever you see quotes around characters, that means it's a string data type. And you can kind of see that what the user was trying, or what the programmer was trying to do here. They were trying to print out a sentence, here's my favorite color. And then they were trying to print out the word green. So in this case, they forgot the quotation marks, like Jesus said. So we need to surround this word with quotes, okay? Otherwise, the computer is gonna think that green is supposed to be the name of a variable, which we have not declared. We haven't created a variable named that yet. And we haven't learned how to create variables yet, but we'll get there. But if we make that edit, if we put those quotes around green, now if we run this, it'll print out, that first line. Hey, Robert. And then it'll go on to print out green on the next line. And then it'll print out, and here's my favorite number. And then it'll print out 5. Now notice that 5 does not have quotes. That means that it is a numeric value, right? In this case, it's an integer or a whole number. So numbers are a different type of data that, you know, they're a number, so they're things that you can add, subtract, multiply, divide, and all of that, and they don't get quotes. Now, so here's the link in case you came in late. There you go. Okay, that's fine. Thank you. We could put quotes around this 5, but then it would no longer be a number. It would be a string, right? But we could still print it out. It will still work. Oh, it's in slow mode. Here we go. Okay, but now you'll notice that when it prints to the screen, it's not a number, it's a string. It has those quotes around it. So there is a difference between, you know, text and numbers. Okay, so in this case, we want the number because we, you know, we're trying to represent a different data type here. So I'm gonna just remove the quotes from the 5, and then I'll put, like I already said, I put the quotes around the word green because I want that to print out. Okay, so one more time, we'll just run that, and it goes through line by line, no errors, and it prints out each message that we want. And for this one, we're just printing to the console. We're not actually affecting the user interface of the application. Okay, any questions so far? And if you joined late, I am recording this, so you'll be able to catch up. Okay, so if you're working along with me and you finished, that's awesome. If you're just choosing to kind of observe at this moment, that's good too. Just make sure that you do the exercises after I release the video today. So I'm gonna go ahead and I'm gonna click finish. And for this next one, let me go ahead and reset this guy as well. Okay, so for this next one, we're dealing with set property calls. So set property is a function that actually affects the user interface. Set property takes 3 different what we call arguments. So 3 different values that affect the screen here. So this first argument is what element we want to set the property of. The second one is what property we actually want to change pertaining to that element. And the last one here is the value we want to change that property to. So this one right here says, hey, I want to change screen number 1's background color to a light blue color. Okay, so let's go ahead and run this. There is going to be an error right here on line 4. You can kind of see where it's predicting something's going to go wrong. But we'll go ahead and see, you know, we get that light blue color. And then the next thing that happens is that the main text changes to welcome to my app. And then something happens here on line 4. So when we are passing in values to set property, they are all going to be strings as long as we don't have a variable declared somewhere. So like blue is a string that we can pass to like either text color or background color, and the code.org language, which is it's actually JavaScript, will recognize this as the color blue. This actually, you know, correlates to an actual color. But since we didn't have the quotes here, it thought that, you know, we had some variable defined somewhere that was called blue. So I could actually give you a preview of, you know, how to actually declare a variable. And we'll see how, you know, this error will actually go away if we do it that way too. So I could type in var, this is short for variable, and then the name blue. And then I can set that to the value of the string blue. And then end that with a semicolon, which is just letting the computer know that that's the end of my command. And now you see that that little warning is gone. That's because now we have a variable named blue that corresponds to the string blue, okay? So if I reset this, this will actually work. So when it gets to line 6, it will actually read this as the string blue and set the text color to a blue color, okay? But another way of fixing this is instead of, creating a variable, we could just put the string directly in here, and that will fix it too, okay? So notice how I can add a comment, these 2 slashes, to comment out pieces of code. So if I put this comment symbol here, it's going to ignore this command that I put here. And this is a really good way to kind of isolate your problem. If you think like, oh, maybe this line is the problem, you can comment it out. Oops. You can comment it out and then see if you still get errors. And if that error goes away, then you know, okay, there's something wrong with this line in particular that I have to fix, okay? So I'm gonna leave this line commented, and now we're gonna run the code again, but this time with the actual string literal here instead of a variable. So go ahead and run that. And so we'll see it kind of goes line by line, no errors. Line 6 is where the problem used to be, and it still works fine. So you could do either way. Either, declare a variable and use the variable here, or just put the string version here. Okay, so I'm gonna leave it like this because we haven't technically gotten into variables yet. Okay, so again, my change was that I surrounded the word blue with quotations, which got rid of my error that I didn't have a variable named blue yet. Okay, any questions on this yet? Okay, so we're gonna go ahead and, if there's no questions, I'm gonna go ahead and click finish on this one. And for the next one, I think this is one that actually has sound in it, so maybe I'll share my sound. Yeah, okay. So let me go ahead and share my sound. And I'm gonna go ahead and refresh this to the beginning. Okay, so this will be an example of a program that has errors, but it doesn't break the program. So you've got one type of error that, causes the program to stop running, and it's called a runtime error, where it starts executing and then it gets to a line that has something funky going on, like a syntax error or something misspelled, and then it just stops. It says, oh, I can't do this anymore. I don't know what to do here. There's a different kind of error called, and I'll put it at the bottom here. This type of error is called a logic error. So a logic error means that the program's still gonna run, it won't break, but it's not gonna do what you want. It'll act in kind of like an unexpected way. So this one has a few different logic errors, but it actually has a runtime error also that we'll see. But notice that there's actually no warnings here at all. See that? There's no warnings at all here. So we have to run this to find out where the runtime error is. So I'm gonna go ahead and I'm actually gonna execute this maybe at medium speed. So it's not super slow, but it doesn't happen too fast either. So let's click run. Okay. So right now it's totally fine because all of these, let me go back to block mode. All of these are event handlers, right? So none of this code is actually gonna run automatically. But now we do see that something did pop up once we actually clicked run. It even gives us a warning in the console. It says line 8, the onEvent ID parameter refers to an ID which rooster IAMJ, which does not exist. So if let's see, this is an event handler that handles if we click on something. But it's yeah, Charles says it's a typo. That's exactly right. So if I reset this guy and I put my cursor over here, I can see that it's called rooster image, not rooster img, right? So this is just a typo. So this is a runtime error that is also a syntax error, meaning that we've got a typo somewhere. So if we fix that and I run it again, that warning goes away. My audio is cutting out. You can try calling in. I see a lot of people calling in. So remember that you can call this number and then put in our meeting ID, which is this one right here. And hopefully the audio will be better. Also, yes, the rooster and pig sounds are mixed. But talking about the audio, I found out the audio issues fix if you install the Zoom program, but the district has to allow you all to do that. So I'll get on them about that again today. So yeah, going back to what Jesus said, there is a logic error, right? So the code still functions, but it works in a way that is not what we want. So if we click on the cow, we can see that there should be a moo sound when the user clicks the cow. So we click it, we hear that moo sound, and then we also notice that the text down here changes to cow, right? If I click on the rooster, we should hear a rooster sound, and then we should see this text change to rooster. But instead, we hear a pig sound, and we see the text up here changes to pig, and this stays the same. This stays as cow. So there's two things that are wrong with this event handler for the rooster. The first thing is that the wrong sound plays. So let me click reset. The wrong sound plays on line 9, right? So to fix this, I can, if I'm in block mode, I can actually click on this error, or this arrow, not error, and then I have the option to choose a sound. And then I could search for whatever I'm looking for. So in this case, I'm searching for a rooster sound, and that pops right up. So I can click that guy, and I can click choose, and then it'll change the sound for me. The other thing is that I wanted to change the text down here, not up here. So this text up here is the application name, and it should always be the same, right? Because the application name should just stay up there. So I noticed that I'm actually changing that text instead of the label that I want to change down here. So the name of this label is animal text. So on line 10, where it says set property of the app name, I want to change this to set the property of animal text. Okay. The other thing that I noticed when I clicked on rooster image is that it didn't say rooster, it said pig, which is not right. So let's change that value from the string pig to the string rooster. Okay. So now if we run that and I click on the rooster, now I hear the rooster and I also see the text being changed down here. Now, Jesus said that there was something also wrong with the pig. So let's click on the pig. And again, we hear the rooster sound, and we also see that the text down here is also rooster. So we need to change those two things as well. So if we scroll down to the last event handler, we can see that this is the event handler for the pig image, which is right here. We notice that the sound that it's playing is the rooster MP3. And last time I showed you how to change it by clicking the arrow, but since we know that there is a pig MP3, we could just highlight this text here and type in pig, and that's the correct name for our MP3. The other thing was that the text down here needs to be pig instead of rooster, so we're gonna set the property of animal text to pig instead. Okay, so now if we rerun this, and now we click on the pig, we'll hear the pig sound, the text changes to pig, test out the rooster again, hear the rooster sound, the text changes to rooster, and then the cow also works correctly. Okay, so those last two errors that we fixed are called logic errors because it doesn't prevent the application from running, but it makes the application run in a way that we didn't expect. So in a way that we don't want it to work. Okay, any questions on this one? All right.
No.
No questions. Awesome. Okay, so let's click finish. And for the next one, okay, this one is pretty fun. So I'm gonna go ahead and restart this one. Okay, so this is like kind of like a little clicker game where you click on the character here and it'll move to like a random position, and it'll also change to a random color as well. But the problem, as we'll see after I click this a few oh, it's not even a click, it's a mouse over. The event here says mouse over. If I mouse over this, eventually it's gonna go off screen because of the number ranges we're using for our random numbers for the X and Y coordinates. So let's remind ourselves, what's the maximum X position we could have while staying on the screen? Yeah, 320, good. 320, and you can remind yourself by mousing over the screen also, yeah. So I'll go ahead and I will annotate that, there we go. So 320 is right here at the very, very edge. And then for the Y direction, yeah, 450. So if we mouse over here, we can see 450. So we'll put that, we'll put the limit like in the coordinates here, right? So 320 and 450, well, technically 450 is down here, right? So like in the Y direction, and then this is the X direction. Let's clean that up a little bit. There we go. Okay. So that's our maximum numbers for the X and the Y. And of course we know that 0, 0, the origin is up here. So when we're trying to create a random XY position, for X, we want some random number between 0 and 320. And we see here on line 3 that we're trying to, we're getting a number that is potentially much larger than that, right? So if we get a number that is larger than 320, which we eventually will, since we see that this gives us a random number between 0 and 400, it's gonna this little guy is gonna wind up going off screen and we won't be able to get him back because the only way that he would change his position is if we moused over him, which becomes impossible because he's not on our screen anymore. And then the same thing with our Y property, right? So we see that it could become a random number between 0 and 500, which is potentially off screen in the Y direction as well. And then once that happens, we can't get him back. So how are we going to fix this then? What lines do we need to change?
3 and 4?
3 and 4, yeah. So we're going to change the maximum values. So for X, that's going to be 320. Oops. And then for Y, it's going to be 450. And so now if we run this again, oh, so this might happen because the image actually starts, if I, is gonna start, I think this image might start from the left corner, which will be technically here, even though it appears white right here. So if it gets exactly 450 or 320, it might still be off screen. So we might want to subtract just a little tiny bit off. So maybe like 300 and 440, let's say. Now let's do 310. 310 and 440. That way we have like at least 10 pixels to work with. So now you can see that you'll still see like it goes somewhat off screen, but at least you can still interact with it, right? And you might, oh, yeah, see, it was like a little bit there. That's why, that's because we could still get like 10 pixels of it. So you might, like, as the programmer, decide maybe you want to subtract even more so it's not so much off screen. So maybe we do want 300 and maybe 430 for our limit. So now we're at least getting 20 pixels of it on screen at all times. That's really up to you as the programmer, right? What effect you want. Now you'll also notice that each time I mouse over it, the color of this object changes as well. And so we haven't officially learned about this function yet. So this is the RGB function. And if you remember, RGB stands for red, green, and blue. So let me clear my screen real quick. So again, it's red, green, and blue. And as we saw in Unit 1, we can combine different values of red, green, and blue to make all sorts of different colors. The last one, A, stands for alpha, which is how bright the color is. And this one's optional, so you don't need to add that one in. So you need to at least pass in the amount of red, green, and blue in there. And how it works for this particular function is it takes a number between 0 and 255 for the amount of red, green, and blue. So 0 is like completely off, and 255 is completely on. Okay, so if I had, 0, 0, 0, that would make black, and if I had 255, 255, 255, that would make white. Don't worry about it too much yet because we haven't officially gone into it, but just know that this particular line on number 2 will change our background, the background color of the smiley, to a random color because we are feeding in a random number for red, a random number for green, and a random number for blue. So every time we mouse over, we get a different random color. Okay? All right, so all we had to do to fix the logic error here was to change the random number maximum for X and the maximum for Y so that it would not go off screen. Okay, and we're almost done. I'm gonna go ahead and click finish. This is the last one I wanna do before we leave today. Let me go ahead and clear my screen. Okay, so this one, let me start over, sorry. Okay, so this one is gonna be super relevant to you because we're gonna learn how to make buttons work so that your application can move to another screen, which is exactly what you'll be doing next week when you start working on your projects again, right? Because your projects have at least 3 screens and you have buttons to navigate to each of those screens. So let's check this out. So if we run this, okay, so we get some music first of all. So we do see that we have a play sound outside of our event handler, so that's gonna go ahead and happen regardless of what the user does. And we also see that it's gonna loop because the loop value is set to true. So this song is going to play forever as long as the app is running. We see we have an event handler for the details button, which is on this first screen right here. And that when we click on it, it calls this function that we haven't seen yet. It's called the set screen function. And what set screen does is it takes in the name of a screen element that you want to change to. So we see that if we click on the event details button, it's gonna change my screen to the screen that is named details screen. So let me click that. And so now we see we're on a different screen here, okay? Right now, if I click on the go back button, it's not gonna do anything because I don't have any event handler for that button, okay? So let me reset this. So here you can see like both the screens are created. But what's happening now is that on the details screen where our go back button is located, we don't have an event handler for it like we do for the details button. So what we're gonna have to do is we're gonna have to drag over an event handler. So that's our on event. Drag that on over. And we want to find the element name of this button. So that's go back button. So I'm going to click on this arrow, and then I'm going to click on go back button. And then my event is going to be click. So when I click on the go back button, I want something to happen. What do I want to happen? Well, I want to set the screen back to my home screen, right? So I'm going to drag over one of these set screen functions. I'm going to find that's near the bottom here of my UI controls section. Click and drag that over. And now I want to, as my argument, I want to provide the name of the screen I want to change to. And that's going to be my home screen. So I'll click that arrow, select the home screen. So now if I run this, I can now not only click event, the events button, to switch to my details screen, but now I can click my go back button and go back to the home screen as well. Okay. So that you're going to be creating probably at least 3 event handlers on your own projects and to enable navigation in your project. So you should really kind of like pay attention, make note of this if you want to jot it down somewhere. This is definitely going to be something that you're going to use on your projects. And then if you are following along with me, you can click on finish. And next time we will talk about the music player, and we'll also talk about the last one, which is our mood minder. And the check for understanding for this one is just a reflection. So we can save that for next time actually, and I'll just adjust the due date for our lesson 7 to be next week. But it looks like we'll finish this up for sure next time. And then next week we'll start back up on the projects where you can start coding your project stuff. All right, let me stop recording.